so 4-4 is our last new lesson for a little bit. There's nothing today you have to do, but there is some stuff I like to do. It makes the problems easier to do. So we have 3 different shortcuts for you. I would say in the homework tonight, try them out, see if you like them. If you like them, use them. If you feel like it makes you worse, then don't do them. Just do whatever you're comfortable doing. In the end, we want to get right answers on the quiz. But on a homework, there's no harm with just trying it, see what happens. If it doesn't work, it doesn't work. But the first shortcut is a thing called clearing decimals. So I think we would agree that it's nicer to work with whole numbers than decimals most of the time. So there's a trick to clear decimals, which is to multiply them all by 10 or by 100 or by 1,000 or some sort of number like that in our mind. What's the shortcut when we multiply by numbers like that, 10, 100,000, when we have decimals?
Just count those zeros.
We can if they're whole numbers, but what if they're decimal numbers we're multiplying by 10?
Moves the decimal.
Just moves the decimal. If it's 10, we move it one spot because there's
2 and 1.
1 0. 100 moves it 2, 1,000 moves it 3. So we've learned all year, whatever you do to one side, you have to do to the other. So if you're going to multiply one number by 10, you have to multiply all the numbers by 10. So here's this trick in action. This decimal has 2 positions. This decimal has 1 position. This decimal also has 2 positions. If you want to have no decimals left, you're going to have to move them all twice. Because the long ones had 2, the short one has 1. So if you do a double move here, you have to do a double move there, you have to do a double move there, and instead of a 0.11, you just have 11. Instead of the 0.2, we made an empty,
20.
That's 20, and instead of the 0.75, 75. I'm feeling like we have enough comfort level, you don't need me to keep solving that, I just want to introduce the trick to you, but if you're uncomfortable, we can do our opposites and work it out if you want. Question about either how I did what I did, or like, what would be next? Let's just talk that out at least. We do it next. To solve this, subtract the 20 and then
Minus 20 on the other side.
and then
Divide.
divide by the
11.
11. The nice thing about dividing 11 with whole numbers is you can, if it doesn't work nicely, you just make a fraction and put the 11 would go on the bottom if it didn't divide evenly. You can't do that with decimals. You can't have a fraction and put decimals in your fraction. So whenever we like move this over to make these whole numbers, first it's easier to work with decimals or with whole numbers than decimals. And second, you can just write division answers as fractions and not have to worry about it too much. Question about that one? So this one, how much movement do I need on this?
2.
2. Because this didn't have, this had 1 decimal position. This didn't have any. And this had 2. So if we move these all 2, this would become
17.
17. This one would become
470.
470. And here's where people mess this trick up sometimes is on this one. What would happen with that one?
Would it just stay the same?
It would not.
It would
300.
It would become 300. Because if we're going to move one of them, you have to move
all of them.
all of them. Where is the decimal in this, but it's invisible?
With A.
It's at the end. There is a decimal there that's invisible. So if you move this twice, if you move that twice, if you move this twice, this makes an empty, so a 0. That makes a double empty, so a double 0. Then where would you go on the opposites from there?
Minus 300.
Subtract 300, then divide by
17.
17. Question about that first trick, what's up with that? Okay, like I said, if you think that helps you, then try it. If you think it might help you, try it. If you really didn't understand that, just don't do it. Just do what we've been doing. Question about that? Second thing we can do. In equation solving land, we're always trying to do the opposite. Okay, so if you see distributing, what is distributing? Is it adding, subtracting, multiplying, or dividing?
Multiplying.
It is multiplying. So instead of doing a multiply where everything's going to get bigger, do the opposite. The opposite of multiply is to divide. If the dividing will cooperate. So instead of distributing 3 and everything gets bigger, think to yourself, can I divide by that 3? If I divide by the 3, x minus 2 is left. This makes sense if 3 can go into 9, which
3.
it does.
Okay.
It's 3. If the 9 were a 10,
No.
don't do that. Okay, if 3 can go into that number, instead of distributing, just divide. And I think we could finish that from there. Question about that? Does that make sense here? Yeah.
Yes.
Because
2 can go into 18.
2 can go into 18. So drop the parentheses in the 2, and in your mind, think about dividing stuff by 2. Over here, if we divide by 2, we get 9, as well as still an x. About that, you need a drink?
I was trying to be quiet.
Yeah, it's all right. We all cough. It's fine.
Can I go get a drink?
Yeah, I'd grab a drink. You seem like a person that could use a drink. I don't need the parentheses there. That's sort of goofy that I did that. Where would we go from here?
Subtract.
I wouldn't subtract the 4 yet.
Would you divide the 2?
I wouldn't divide the 2.
Mul-
I wouldn't add 4.
Multiply it?
I would not. What's the issue with this? We've only seen this for like 2 or
There's
3 days.
2 x's.
There's an x on the left as well as
On the right.
an x on the right. So what we'd have to do is get rid of one or the other. It'd be a little weird to get rid of this one because it's the only thing over there. There'd be nothing left if we got rid of that. It would equal 0, and that's a little bit weird. How would you get rid of this one?
Subtract.
Subtract 2x. Let's do that one because we had a little trouble there. Leave the negative 4. To get rid of this, we subtract 2x. Gets us 7x. Answer,
Negative 4.
negative 4 on top of 7. Something about that. This one. The trick sort of works, but it's not as great as the other one. Why is the trick still in play?
There's some on the. Oh, the 5 goes into 25.
5 can go into 25. So we could drop the parentheses for the 3x minus 4 side. We could turn the 25 into 5. But this other stuff is still going to need to have what happened next for us to continue down the road.
Distribute.
We'd still have to distribute and do some things. Question about how that trick worked on that one. Here's what will blow the trick up is if there's more numbers. So let's say this had a plus 5. Then that trick is dead. Because it's not enough that 2 goes into 18. If we're going to attack one of the numbers, we have to attack all of them. So if 2's going into 18 to make 9, and that seems good, this is a failure because 2 does not go into 5. Don't try to use that trick. If the 5 were a 6,
Yes.
yes, now that would become a plus
3.
3. If I had another plus thing here, let's say I have a plus xy thing going on there, what would be a number I could draw here that makes the trick still good?
1.
No, 1 would be bad.
Oh, yeah,
A number I could stick there and the trick is still in play? 6. Why is 6 good there? Because 3 goes into 6. What if I had 7?
No.
No, don't do the trick, because 3 doesn't go into 7. So if we can go into 1, we have to go into all. So if I wanted to tack on another number here, if I want the trick to still work with 5, I'd have to do a number that will be a good example of a good number that I could still run the divide trick.
15.
15 would work, because 5 goes into that. But if I did like 14, no, it doesn't work anymore. Question about that? Here's something, maybe this is an Algebra 2 problem, but let me go back to this for a second. If I had something like this, I don't know if your book does this or not, but just in case. Let's say I have something like that going on. What number is here? Invisible. 1. If I'm going to bounce twice, and bounce twice, and bounce twice, even though this didn't have a number, it would need to bounce twice, and it would turn into 100. But the parentheses wouldn't get touched. You're not going to touch anything in the parentheses. When you turn this into 100, you're covered. Because what's 100 going to do next? It's going to distribute and get them both. So if you got this and you got those, there's pieces that you really got twice. You don't want to get stuff twice. You want to get everything once. So if they had like a secret parenthesis thing going on, there is a 1 there, and it's a bounce. I don't think your book does that. I think I'm having an Algebra 2 flashback, but just in case. Question about first 2 tricks? And we'll see if we can manage a turn today. Or a move. A turn or a move or a something.
There we go.
Nice and smooth.
Oh, yeah.
Alright. This is the best trick that people, I think, have the most success for. If you ever see something that is an exact match, 1 on each side, you can just completely eliminate it. So I'm just going to break out the eraser for this trick. So if I give you this, who's a duplicate on both sides?
-4 and -4.
Minus 4x, minus 4x. Just take out your eraser and do that. If you're doing homework, even better, don't even use your eraser, because when you copy the problem down, don't copy all of it, only copy what you need. So here's a big, giant, monstrous, long problem that can ditch a ton of stuff. Who could go?
The 2 X's.
Here's a positive 2x. There's a positive 2x. Ditch them both.
What about the one on the end?
7X.
I see a negative 7x, and I see a negative 7x.
Would the one on the end go already with the other ones?
Did we erase a pair of 2x's?
Yeah.
We can only do one on each side at a time. So we can't, the only way we can get rid of doubles on one side.
Negative 11x.
Negative 11x, yeah. The only way we could get rid of doubles is if we had doubles on each side.
The +6 and the +6.
Plus 6, plus 6.
The 4 and the 4.
The positive 4 versus the positive 4.
Just be 2
So this boils down to 2x equals 3, okay? Could we have combined like terms and done all kind of stuff? Sure, we could have. The one extra credit problem, if you remember, Vivian suggested we erase something the one day on the extra credit problem, and I'm like, hang on, we didn't really learn that yet. You know, now that would be a better trick in play. This answer would just be
Is positive 2x.
3 over 2.
3 over 2 would be the final answer on that. Something there. Then here's a crazy question that does all of that stuff all in one swoop. Something,
Take out the -10.
we could go -10. So -10 is a good match for -10. We could drop those. That used like trick number 3 of the day.
Divide the...
Distribute.
Instead of distributing,
Divide by 5.
divide 5 into
3.
15. So 5 is gone, parentheses are gone, 15 turns into 3. That used trick 2 of the day.
Move the decimal
Move
twice.
the decimals twice, so this would be
3x.
30.
30x.
4.
4,
30.
100.
300.
Ah.
Because this has that invisible decimal. If you're going to go twice there, we've got to go twice here and there. And then just go do stuff. 30x would be
296.
296. X would be, for a second, making it harder than it needs to be. Just to get us started, put
296 over 30.
just put 296 over 30 to have something, just divide. Can any numbers go into both of those?
2.
2,
Um,
good bottom, 15 on the bottom,
143. 8.
and that's as good as that's gonna get. The only stuff that goes into 15 is 5 and 3. 5 absolutely doesn't go into this because
It's not
It
5 or
does
0.
that.
it doesn't end with 5 or 0. And what's the quick check for 3s? Add up the digits. Add up the digits, they add up 13. So get out of there. 148 over 15. Stop. I trust you on the cross-out trick based on your performance in class. I think I trust you on the distribute as well, based on performance in class. I'm a little distrustful of you on the decimal move over thing, because you don't like to move over the ones that make empties. So if you are doing the move over thing, make sure you're finding your empties, especially which kind of numbers just wrecked us every time I did one of them on those move overs.
Single digits.
Yeah, like the whole number, the single digit whole numbers. So if I'm dropping you a 3, make sure you drop in a 3 with a decimal at the end and do the move over. And the 3s need to be like 300s or 30s or 3000s or something. So I don't know if I trust you on that. You could adjust and be fine, but if you don't adjust and be fine, you're going to wreck all your decimal problems. Make sure you move them all over the same amount, including ones with empties and including ones with holes. Game plan, today's Friday on this calendar. Who knows if people watch videos other years what day of the week it'll be, but we'll have a book homework due next class, which for us is Monday. That assignment is 150. We're working 1 to 24, skip a little bit, do 36, skip a little bit, and do 49. And then I'm going to give you a sheet today, even though it's not due till Tuesday. If you want to work ahead, you can. If you don't want to work ahead, just don't lose it. So 2 classes away, this paper will be due. 3 classes away, we'll take a quiz that's just like this paper. You will need your book next time I see you, because we'll want to go through the homework. That'll be all we're trying to do. But then you won't need your book for a couple days while we do this sheet and do the quiz that's like this sheet. Anybody have a question that's like beneficial for the recording part of this thing? Let's shut that on down. You were in line.